Hello everyone, my name is Monit and in today's session we will solve IBDP Physics High Level Paper 2 of October-November 2020. Before going on, please read all the instructions provided to you. So let us start with the very first question. Question number 1. A company delivers packages to customer using a small unmanned aircraft. Rotating horizontal blades exert a force on the surrounding air. These are the blades, these are exerting a force on a surrounding air. The air above the aircraft is initially stationary. Here the whatever be the air is initially at stationary. The air is propelled vertically downward with speed v. The aircraft moves motionless above the ground. It is not moving. Okay. A package is suspended from the aircraft on a string. You can see in the diagram. The mass of the aircraft is 0.95 kg. So you can see that the mass is 0.95 kg and the combined mass of the package, this is mass of the aircraft. So this is the mass of the aircraft and the mass of the string is package and string is 0.45 kg. The mass of air pushed downward by the blade in 1 second is 1.7 kg. So this is the mass of air that is pushed down by the aircraft in 1 second. Now in the first part, state the value of the resultant force on the aircraft when hovering. So we know that when hovering it is stationary, it is not either moving upward or downward. So in that case we know that the downward force must be equal to the upward force or the vertical forces must be balanced. So 0 because the resultant force will be 0 as while hovering the forces are balanced. So this is of 1 mark only. Now second part, outlined by reference of Newton's third law. We know that Newton's third law states that every action has an equal and opposite reaction. So how the upward lift force on the aircraft is achieved. Now we know that these blades are pushing the air in the downward direction. So that is the action. So as the blade exert a downward force on the air, thus by Newton's third law an equal and opposite force exert in the form of upward lift force. So this is of 2 marks. One you have to show what is the action and one you have to state regarding the Newton's third law with reference to the Newton's third law. Now the question number 3. Determine V. State your answer to an appropriate number of sig f's. So if you determine V, in the question it is given that V is the vertically downward with speed v. The air is propelled with vertically downward speed v. That is the we have to calculate. So we know that lift force is rate of change of momentum, that is delta m over delta t times the velocity, which we have to find it out speed. So delta m by delta t is 1.7 kg per second, that is given in the question. So the lift force can be written as 1.7 v. Also lift force is equals to the downward force because it is hovering. So it is neither moving upward or downward. In that case the forces must be balanced. So using this 1.7 v equals to the total weight in the downward direction, that is combining the aircraft and the string and package itself. Multiplying it with g 9.81 you will get 8.0878. Converting into appropriate number of significant figure, that is 2 significant figure, rounding off we will get 8.1. Okay. Now this fourth part is only for HL students. Okay. So calculate the power transferred to the air by the aircraft. We know that power is nothing but the energy transferred per unit time. So by using that formula we can take the, because it is having some velocity, so we are considering the kinetic energy. So kinetic energy per unit time half mv square upon delta t. So delta m over delta t we know that 1.7. V we have already calculated in the above part, which is 8.1. So by putting up the values and converting into 2 significant figure, we got the answer 56 watt into 2 significant figures. Okay. So 1 mark is for using the equation for the power and 1 mark for the correct answer. Now the B part, this is an SL also, okay, don't, only the fourth part is not there, rest all the parts are in SL. The package and string are now released and fall to the ground. Now the package and the string are released. The lift force on the aircraft remains unchanged. This is very important statement, that the lift force on the aircraft remains unchanged. Calculate the initial SL. Now what is happening, lift force which is lifting it in the upward direction is remaining the same, but now the weight which was acting in the downward direction has been released. So we have to, now what will happen is the aircraft will start to accelerate in the upward direction. So we have to calculate the initial acceleration. So in that case, now the vertical force is equal to the weight of the package and the string. So vertical force is which is moving the object in the upward direction, because that is the force has been released, the weight has been released. Now this weight will be responsible in the upward direction, so that it will move in the upward direction. So that is 0.45 into 9.81. so we know that the vertical force will be equals to mass into acceleration. So acceleration will be force upon mass. Using this we get the answer 4.6 meter per second square. So 1 mark for calculating the vertical forces and 1 mark for equating to find out the acceleration. If you have any doubt, you can comment in the chat box. I will be able to answer as soon as possible. Okay. So question number 1 is clear. Now question number 2. A rotor in an amusement park ride that can be modeled as a vertical cylinder of inner radius r rotating about its axis. So this is the axis you can see here. When the cylinder rotates sufficiently fast, now this is rotating very fast, the floor drops out and the passengers stay motionless against the inner surface. This is the inner surface of the cylinder. The diagram shows a person taking the rotor ride. The floor of the rotor has been lowered away from the person. So you can see here it is lowered away from the person. Draw and label the FBD of the person. So you can see here it is not moving anywhere. So what are the forces acting is, the first one is the weight which is acting in the downward direction. The one which is responsible for the person to stick to the wall is your friction, which is acting in the opposite direction, and the normal reaction force which is acting perpendicular to the surface. So this is of 2 marks. Please remember that the magnitude of the friction, the vectors which you are drawing, the weight and the friction vector should be equal. The length of the vector should be equal. Otherwise, that will give you an idea that these forces are unbalanced. So make an idea while drawing that the length are equal and the normal reaction is in the perpendicular direction with the wall of the cylinder. So this is of 2 marks. Now B. The person must not slide down the wall. Show that the minimum angular velocity omega of the cylinder for this situation is this. So we just have to equate the forces. If the person is not sliding, so the friction and the weight must be equal. We know that friction is nu times n, where nu is the coefficient of friction, n is the normal reaction force, w is the weight, and n will be, that is, it is moving in a circular motion cylinder. So n will be nothing but the centripetal force, which is m omega square r. This is the centripetal force. Okay. Fine. W is mg. Equating these, you will get the required angular velocity. Okay. So this is the minimum angular velocity. In the C part, the coefficient of static friction between the person and the cylinder is now 0.40. This is the value of nu given to us. The radius of the cylinder is 3.5 meter. The radius is also given. And the cylinder makes 28 revolutions per minute. Deduce whether the person will slide down the inner surface of the cylinder or not. So using this, the same equation which we have shown above, we can find out the value of omega by just putting up the value, that is g upon mu r. which is 2.6 radian per second. Also we know that angular velocity is equals to omega equals to 2 pi upon t, where t is the time period. Now in the question it is given that it is revolving 28 revolution per minute. So what is will be the time period? That will be in 1 second, or you can say for one revolution it will take 60 upon 28, that is the time period. So this is the time period for one revolution. So by putting up the value we get 2.9 radian per second. So this is the minimum required angular velocity, which is 2.6, and this is the actual angular velocity, which is 2.9. So we know that if the actual angular velocity is greater than the minimum, so the person will not slide, because this velocity, angular velocity, is greater than 2.6, which is the minimum required. So if it is more than minimum required, then the person will not slide. If this value comes out to be less than 2.6, then the person will slide down towards the surface. The second method you can compare by solving the actual friction and the minimum friction. The actual friction is nu n, which is acting in the upward direction, and the minimum friction required is the weight, which is acting in the downward direction. So by using these two, that is nu n, value of nu n, and value of weight, you can say that the person will slide down or not. If the actual friction is greater than the minimum friction, the person will not slide. Okay. Now the question number 3. A sample of vegetable oil initially in the liquid state is placed in a freezer that transfer thermal energy from the sample at a constant rate. The graph of how temperature varies with the time is given to us. Now the first question, these are the data given: mass of the sample, latent heat of fusion of the oil, and rate of thermal energy, that is the power is given to us 15 watt. In the first part, calculate the thermal energy transferred from the sample during the first 30 minutes. So you can see it is asking for the first 30 minutes how much amount of energy has been transferred. So the energy is transferred at the constant rate, that is power. So power is equals to energy upon time. So energy will be power into time. So power is 15 watt, time is 30 minutes, then converted into second. So we get 27 kilojoule, that is of 1 mark. Second, specific heat capacity we have to find out for the liquid phase. Okay, so we know that up to time 30 minutes the temperature is decreasing, so it means that it is in a liquid phase. So using the formula E equals to mc delta T, E we have already calculated for 30 minutes. Mass is given 0.32 kg. C we have to find out, and change in temperature is, you can see from the graph, from 290 to 250 is the change in temperature. By just putting up the value and converting into the required significant figure, we get the specific heat as 2100 joule per kg per Kelvin. So this is of 2 mark, 1 mark for the correct equation and 1 mark for correct substitution and getting the correct answer. Now the B part, a sample begins to freeze during thermal energy transfer. Explain in terms of the molecular model of matter why the temperature of the sample remain constant during the freezing. We know that while the phase is changing place, the temperature remains the same, but this we have to explain with reference to the molecular model of matter. So we know that according to molecular model, when the sample begins to freeze, intermolecular bonds are formed. This is very important. And potential energy of the molecule decreases. By forming of the intermolecular bonds, the potential energy of each and every molecule decreases, but the average random kinetic energy of the molecule does not change. And we know that temperature is directly related to your kinetic energy. Using this, you can see here, kinetic energy of the molecule is 3 by 2 kT, where K is the Boltzmann constant, T is the temperature. So we can say here is kinetic energy is directly proportional to the temperature. If the kinetic energy is not changing, then temperature will also not change. So hence the temperature of the sample remain constant during the freezing. I hope you get it. If you have any doubt, you can just comment below. The 3 marks is reference to the intermolecular bonds, that there is decrease in potential kinetic energy. Second point, average kinetic energy does not change, and 1 mark for that temperature is directly related to the kinetic energy. Okay. Now the C part, calculate the mass of the oil that remains unfrozen after 60 minutes. So till here, how much mass of the liquid or the oil does not freeze, that we have to calculate. So mass of the frozen oil will be E upon L, because we know that E is equals to ml. So mass will be E times by L. So this is the mass of the frozen oil. Okay, that mass of the oil which has already been frozen in 60 minutes. So energy supplied in 60 minutes, again power times power into time, power is 15, time is power is, okay, this is mass of the frozen oil, that is this time, we have to take this duration because this is the time over which the change of phase takes place. So this is 30 minutes. Okay, so the energy supplied during this time is 15 into 30 into 60 divided by latent heat of fusion of oil, which is given in the question. We get 0.21 kg by rounding off into two significant figure. Okay, so this is the mass of the frozen oil, and the total mass of the oil is 0.32. So the unfrozen oil we will get it subtracted by 0.21. So we'll get 0.11 kg as the answer. That is the mass of the unfrozen oil, which is still supposed to be frozen if we continue supplying the thermal energy. Okay. Now the question number 4. The two loudspeaker A and B are driven in phase, with the same amplitude at a frequency of 850 Hz. So these are the two loudspeaker which are driven in phase and have the same amplitude, and the frequency of both is 850 Hz. The point P is located 22.5 from A and 24.3 meter from B. The speed of the sound is 340 meter per second. We have to deduce a minimum intensity of sound at P. So if they are in phase, so we can say here that the wavelength is speed upon frequency. By wave equation we know that speed is equals to f lambda, so lambda will be equals to v by f. So v is 340, f is 850, so we get the lambda, that is the wavelength of the sound, which is 0.4 meter. Now the path difference, if you can see here, the path difference is 24.3 minus 22.5, which is 1.8 meter. So this is the path difference. So how many variations are there of the wavelength? So 1.8 equals to n lambda, so we get the value of n as 4.5. It means that when they are meeting, they have covered 4.5 wavelength. So therefore waves, it is in 0.5, or you can say in the half terms, it is not of a particular value. So the waves from destructive interference at P, which shows that there is a minimum intensity of sound at P. So they are in destructive, they are forming a destructive interference because we are getting n in terms of 0.5. Okay. Now the B part, a microphone moves along the line P to Q, which is normal to the midway of the loudspeaker. The intensity of sound is detected by the microphone. Predict the variation of detected intensity as the microphone moves from P to Q. Now we know that at P what we are having is the lowest or the minimum intensity of sound. So as we are moving here, you can see here, and this is at the midway, so they will be in the same phase, they will form a constructive interference. So as the microphone moves from P to Q, the intensity will vary as a series of equally spaced maxima and minima, because it is moving perpendicular to the midway line. So at P it is minimum, so it will go maximum, then again minimum, maximum, minimum, maximum, minimum, maximum, minimum and maximum. So it will be 4.5 because the phase difference was initially, path difference was initially 4.5. So you can see equally spaced maxima minima where the intensity is minimum at P and maximum at Q. When it reach Q, the intensity will be maximum and at P it will be minimum. So you have to show 1 mark for the equal series of spaced maxima and minima and 1 mark for minimum at P and maximum at Q. Okay. Now the C part. So when both the speakers are operating, the intensity of the sound recorded at Q is I naught. The loudspeaker B is now disconnected. We have disconnected loudspeaker B. Initially at Q we are hearing the intensity I naught. Now we have disconnected B. A continues to emit sound with unchanged amplitude and frequency. The intensity of sound recorded at Q changes to IA. We have to estimate the ratio of IA upon I naught. So when B is disconnected, amplitude of the Q is half because amplitude or intensity have this relation. Intensity is directly proportional to the square of the amplitude. So we can say that the intensity of A becomes half because one of the speaker has been disconnected. So A by 2 square and I naught having the intensity A square. So by solving you will get the ratio as 1 by 4. So 1 mark for this and 1 mark for the final answer. Now this is for the HL only. D part, rest all are for SL. Look, I will only mention the HL only which are here, rest all are in SL, so the SL student can skip this part. Okay. In another experiment, loudspeaker A is stationary and emits sound with a frequency of 850 Hz. Now the speaker A is stationary, the microphone is moving directly away from the loudspeaker with a constant speed V. Now the microphone is moving away with a speed V. The frequency of the sound recorded by the microphone is 845 Hz. Now this is an question of a Doppler effect where the frequency observed changes with respect to the original frequency or the frequency of the source due to relative motion between the source and the observer. So explain why the frequency recorded by the microphone is lower than the frequency emitted by the loudspeaker. So we know that the speed of sound relative to the microphone is less because it is moving away. So the wavelength is unchanged, thus frequency also decreases. We know this V is equals to F lambda. Here is the equation, this is given in your physics booklet. So if lambda is not changing, so speed of sound decreases relative to the microphone, so the frequency has also to be decreased, and that is why we are getting a value less than 850. Now in the next part we have to calculate V. So this is the formula, moving observer. Here the observer, that is the microphone, is moving. So we will use this formula. This is provided in your physics booklet. You can refer there. So the frequency observed is 845. The frequency of the source is 850. The speed of sound is 340. Why we have used this negative sign? Because it is moving away. So relative speed is decreasing. That is why we are taking it minus. If the microphone is moving towards the speakers, then we have taken it as plus, and then the frequency have been rises. Okay. So this is the value of V while calculating. So 1 mark for the correct equation and 1 mark for the correct answer. You can just calculate on your own. Okay. Now question number 5. The graph shows current I which varies with the voltage across a component X. You can see it is the curved line. Okay. Outline why component X is considered non-ohmic, because we know that if their component X was following the Ohm's law, then the current is directly proportional to the potential difference, so that we get a straight line. So here it is a non-ohmic, so it is not directly proportional to the potential difference, and that is why it is considered as non-ohmic. Now component X and a cell of negligible internal resistance are placed in a circuit. A variable resistor R is connected in series with component X and the ammeter reads 20 milliampere. Determine the resistance of the variable resistance. So from graph, this the component X graph we are given. So we can see here from graph at 20 milliampere, if we are getting an ammeter reading of 20 milliampere, at this the component X is having a potential drop of 2.3 volt. Okay, so Vx is 2.3 volt and VR using the Ohm's law is I times R. So R will be VR by I. We have to calculate the resistance now. So VR by I. So VR, the potential drop at VR will be total voltage minus voltage drop at X, which is 2.3. So V minus 2.3 upon current, which is in series, remains the same, 20 milliampere. So we are getting the value of variable resistance as 85 ohm. So 1 mark for getting this value, 1 mark for using this equation, and 1 mark for getting right answer. Now the second part, power dissipated in the circuit. So power is V times I. V is for the complete circuit it is asking. So V is 4, current is given. So it is 0.080 watt is the answer. 1 mark, simple. Now the question number C part, exponent X and cell are now placed in potential divider circuit. Now this is the cell and this is the component X. This is a potential divider circuit. State the range of the current that the ammeter, this ammeter, can measure as the slider S, this is the slider S of the potential divider is moved from Q to P. So we know that when the slider is at Q, there is no potential drop. So all the potential drop will be here. So there will be no current flowing in this branch of the circuit. So the ammeter will read at 0. As soon as the slider moves towards Q, all the voltages drop at X. So all the current, that is the maximum current from the graph, we can consider at 4 volt. At 4 volt from the graph, this is the 4 volt. At 4 volt, what is the value of current? That is 60 milliampere. Because all the voltage has been dropped at X. So at 4 volt, the current will have 60 milliampere. Now the second part, slider S of the potential divider is positioned so that the meter reads 20 milliampere. Now the divider is positioned in such a manner that the ammeter reading is 20 milliampere. Explain without further calculation any difference in the power transferred by the potential divider arrangement over the arrangement in B. So we know that overall power is greater in case of potential divider over the arrangement in B, because the total resistance decreases when X is in parallel with the SQ. As you see in the arrangement in B, what is the arrangement in B part? These are connected in series. So the resistance will in series will be greater than the resistance in parallel combination. Okay. So we know that power is equals to V square by R. So when we have connected it in the potential divider, that is the parallel circuit, the power will be maximum. So that is why I have written the power is greater in the case of potential divider, because it is a parallel combination. It is parallel because the total resistance decreases when X is in parallel with SQ, and in the B part it is in series. So we know that R series is greater than RP. So power in parallel will be greater than in power in series. Okay. That was a good logical question. Now the question number 6, that is the last question for the SL student. The next question we will discuss it in the next video. For the HL student, please watch the next video as well. Okay. So the question number 6, a possible fission reaction of uranium is given to us. These are the following data available to us: the mass of one atom, the binding energy of uranium, xenon and strontium. These are the in mega electron volt, and the mass of one atom is given as atomic mass unit 235. State what is mean by binding energy of a nucleus. That is the energy required to completely separate the nucleons of a given nucleus. That is a direct question. Second part, outline why quantities such as atomic mass and nuclear binding energy are often expressed as non-SI units. So the reason for expressing these in the non-SI unit, because if we have done it in the SI unit, it would get a very small unit or the very small value, which will be sometimes very tedious to write it again and again and to solve the numericals. So that is the reason why we have taken a atomic unit or atomic mass unit for such type of calculations. Show that the energy released in the reaction is about 180 mega electron volt. So we have to just use the data's energy released will be 140 times 8. What is 140? That is the energy released here minus energy of the uranium. So binding energy, that is what we are discussing. So per nucleon, so here are 140 nucleon. So 140 times 8.29 and 94 times 8.59 minus 235 times 7.59. So that is what I have written here. Here. This is the nucleon number and this is the binding energy per nucleon. So by solving, you will get a near about into two significant figures as 180 mega electron volt. Now the B part, it uses a uranium-235 as fuel. Assume that every fission reaction of uranium gives rise to 180 mega electron volt of energy. Estimate in joule per kg the specific energy of uranium-235. So first of all, what we will do is we will convert this energy into joule. So 180 into 10 raised to power 6 is the mega electron volt, multiplying with the charge of an electron to convert it into joule, and the mass we will be converted into kg. It is given in your atomic mass unit. You can use this data that is already given in your physics booklet, that 1 U is equals to 1.661 into 10 raised to power minus 27 kg. So multiplying with the atomic mass unit of uranium, which is 235. So specific energy is nothing but energy per unit mass. So this is the energy we have. You have to just divide this by mass. So you will get 7.378 into 10 raised to power 13 joule per kg. You can do the calculation on your own, and by rounding off you will get 7.4 into 10 raised to power 13 joule per kg. So that is the estimate of the specific energy, that is mass per unit, energy per unit mass. Okay. Now the power station has a power output of 1.2 gigawatt and efficiency of 36%. Determine the mass of uranium-235 that undergoes fission in 1 day. So energy produced in 1 day, what we can do is, this is the amount of useful output power and the efficiency is 36. So we just multiply the power into that is the energy produced in 1 day, that is the power times power into time. So that is power in 1 day 24 hours and converted into second, that is 3600. So this much is the amount of energy which is produced in 1 day. Now the efficiency is 36%. So what we will get as the output, dividing it by the percentage of the efficiency. So this is the amount of energy which we are actually getting in 1 day. Again, we have to calculate the mass which has been used in 1 day. So energy upon the specific energy of the uranium-235, which we have calculated in the above part. So 2.9 into 10 raised to power 14 upon 7.4 into 10 raised to power 13, you will get a value of 3.9 kg. So this much amount of mass of uranium-235 has undergone fission in 1 day. Now the third part, the specific energy of the fuel is 30 megajoule per kg. With reference to your answer in the first part, one advantage of uranium-235 compared with the fossil fuels in a power station. So you can see here the value which we are getting for the per mass is 7.4 into 10 raised to power 13 joule energy we are getting by 1 kg of uranium, which is a very huge amount. Okay, So if we compare with the fossil fuel, to produce same amount of energy, less fuel is used in case of uranium 235, or you can say in the other term also, a small amount of uranium 235 produces a large amount of energy as compared to fossil fuels. Any of the way is right. Now the C part, a sample of waste produced by the reactor contains 1 kg of strontium 94 and is a radioactive and undergoes beta minus decay to form a daughter nuclei X. This is the reaction. Write down the proton number. So we know that if it is going a beta minus, so there will be an addition in the atomic number or the proton number, so we will get 39 because it is going beta minus decay. The graph shows the time of the mass of strontium with the remaining sample. At initial it is having 1 kg, as you can see the graph is going. State the half life. So we know that half life is will be at 0.5, so you can see here it is 75 second, 1 mark. Calculate the mass of strontium 94 remaining in the sample after 10 minutes. Okay, so after 10 minutes, 75 second is how much? That is 1.25 second, 1.25 minute. So how many half cycle will be there in a 10 minutes? So 10 divided by 1.25, that is 8 half cycle it has been already completed after 10 minutes. So 10 minutes is 8 times of its half life, and we know that its half life is how much? So mass remaining, we have to calculate the mass. So 1 kg is the initial and it will go 8 half life, so 1 by 2 times 8. So this remaining mass will be 3.9 into 10 raised to power minus 3 kg. Okay, so this is where we are ending this session as of now. We will continue the remaining question for the HL students in the next video. Please go to the next video, and if you want the online classes for IBDP physics, high level or standard level, these are the online classes highlights. You will get the high quality PDF notes of each session. Right now how I am writing, you will get in the same manner. There will be full curriculum covered, comprehensive study material will be provided, one-to-one support, and with a session will consider very interesting simulation and the add tools. If you want to contact, you can WhatsApp to my number. For more details, please contact at this WhatsApp number. Okay, so these are the courses available, you can refer, and this is the information you will get. Okay, one more thing important, to get the PDF of this video, you can just go to my website. The link is given in the description. You can download the PDF of this video by just going through my website. Okay, thank you.